As we start into section 11.3, one thing I can tell you, it's very similar to that of 11.2. There's two objectives in this section. One is to compute and interpret a Z-score for data that's standard normal, and we talked about that yesterday a little bit already. And then we're going to transform the standard normal Z-score and find probabilities. So we're going to use the probability curve of the standard normal curve, but we need to find our Z-scores today versus them giving us the Z-scores up front. So not that much different. Let's start. Again, we touched on this the other day. What is a Z-score? The Z-score by definition is right here. It says this is our piece of data, this is the mean, and this here is the standard deviation. So the only thing different in today's slide from yesterday's is the mean here is called mu, and this is the population mean. And this is, here is the sigma, and this is the population standard deviation. What you're used to seeing for our Z-score calc is we used to take our piece of data minus x bar over s sub x. They mean the same thing. This is the mean, but that's the mean of a sample. This is the standard deviation, but that's the standard deviation of a sample. So today we just need to change the vocab to the population. We use statistics to make inferences about the population. So let's just go ahead and actually look at some examples and compute the Z-scores. We're going to plot it on the standard normal curve and then use that table of data to find the probability under the curve. Now in this example it says use the information given on page 698. What they tell you is they say mu, again that's population mean, is 183 centimeters of an adult Dutch male. And this is sigma, or standard deviation of the population, is 6.7 centimeters. Which means on average, if I randomly select someone in the population, he will be either above or below the mean by 6.7 centimeters. And again, this mean here is for the population. We're used to seeing x bar, and we're used to seeing s sub x. And those are for the sample. So it says here, an adult Dutch male is selected randomly. What is the probability the man is less than 188 centimeters tall? Now, we need to make the assumption that the heights of Dutch men are standard normal distribution. So if you were to gather all the data about a group of men from Dutch, or from the Netherlands, you would see that their heights create the standard normal curve. So sketch a quick curve. Now, we need to figure out what Z-score we want. Remember, this is the Z-score of 0. Well, the 0 Z-score means the average here, so I'm actually going to jot down, this is our 183 centimeter male. We want to figure out how many Z-scores 188 centimeter male is in terms of this. Clearly, they're above it. Well, let's compute it. The Z-score is your piece of data minus the mean over the standard deviation. When you do this, you get a Z-score of 0.75. Remember, our Z-scores are going to typically range from +3 to -3. So I'm going to put in the 1 and the 2. And we're talking a 0.75. So the 0.75 is going to be about right here. So this is a Z-score of about 0.75. They want to know the probability that a man is less than that. So they want to know this area under the curve. Okay. And that is associated with the 188 centimeter male, by the way. So go to the table in the front part of the packet, look up the Z-score of 0.7, and then find 5, and we'll get this. I'm going to write the probability that the Z-score is less than 0.75. I look in the table. The area under the curve is going to be 0.7734. So the probability is a 77.34% chance if I randomly select a male in this certain population that his height will be 188 centimeters or shorter. And that's how you're going to do the problems today. I want to look at a couple more examples. Something a little more close to home for you might be ACT scores. So let's take a look at this. ACT scores are very close to normally distributed, with a mean of 21 and a standard deviation of 4.7 points. From that information, about what percent of ACT test taker scores are below 24? Okay, let's just go ahead and do that part. It says here, to calculate the Z-score, they want us to use 23.5 rather than 24 because the standard normal distribution is continuous and ACT scores are integers. So that's just a fact they're giving us. They would have had to tell us that, otherwise we would have used 24. Fine. Let's find the Z-score. So we're going to use this. Assume here that the mean of the population, again, is 21. The standard deviation of the population is 4.7. The piece of data they want us to analyze is 23.5. Let's compute the Z-score. The Z-score is going to be this. It's about 0.5319 is the Z-score. So if we plot that on the standard normal distribution, we'll see a curve, looks something like this. Again, this is a Z-score of 0. I'm going to tick in 1, 2, and 3, just so I space it out well. And we'll pop in our Z-score, which is right here, about 0.5319 is the Z-score. Now, what is the question? What they want to know is this. About what percent of test takers are below that Z-score? So what is the probability that the Z-score is less than 0.5319? Go to your table, look up 0.53, and here's visually what they want us to find is the area under the curve here. When you do that, you're going to get the probability is 0.7019. So about 70.19% of the ACT test takers have an ACT score of 23.5 or lower. If they had asked us what's the probability a person has a score higher than that, we would just take 1 minus that number, and that would give us the red tail. So roughly 30% of the students have a 23.5 score or higher for the ACT exam. This is another example I would listen to, and then I'll do one more if you need some more information. Here we go. A machine fills bags with popcorn. If the bags are underfilled, there will be complaints from the consumers. If bags are overfilled, they cannot be closed and sealed by the next machine in the production line. The bag states that there are 7 ounces in a bag. Circle that. The company has chosen to fill each bag with 8 ounces of popcorn on average. Assume the quantity of popcorn in each bag is normally distributed with a standard deviation of 0.6 ounces. Part A. What percent of the bags are likely to be under the stated weight of 7 ounces? So here's the question. What's the probability that the bags themselves are less than 7 ounces? To find that, I want to find its Z-score. So I'm going to convert this to the Z-score. What's the probability the Z-score is less than? Our Z-score here is 7 ounces is our piece of data. The mean is 8. Standard deviation is 0.6. That is the probability that the Z-score is less than negative 1.67. Now, we have to be careful when you find this. The probability table only gives us positive Z-scores, so you have to think how to back into this answer. The way I like to do this is first just sketch out the scenario. So if we do this, let's do it right here. Here's the scenario. That's a Z-score of 0. They want us to find approximately, let's say this Z-score is negative 1.67. And then the probability that the Z-score is less than that. So they need this tail. Okay. If you look at the table of the normal distribution probability, the area under the curve, it only gives us positive numbers. So that table can only give us this. It can give us the positive 1.67. So if we use the table, we can find the area here in the green.
That area in the green, when you look it up, is going to be, for 1.67, this is going to be 0.9525. Now the thing about this curve, it has that great symmetry. This red tail right here is going to be the same as this red tail right here. So we can easily find the answer to this tail over here on the left by taking 1 minus the probability that we found. So what I'm going to do here is do 1 minus the 0.9525, and we're going to get that the probability is about 4.75% chance that the bags are going to be underfilled. Okay, the next problem is just some more practice. Here they say if the manager purchases empty bags that can hold 10 ounces, then what portion would be filled over capacity? So here they want to know what's the probability that the bags are going to be bigger than 10 ounces filled. So we're just going to find the z-score that goes with that. So the z-score is going to be bigger than the 10 minus 8 over 0.6. That question really is, what's the probability the z-score is greater than 3.33? Okay. To find that, sketch the curve again. I'll do a curve right here. If the probability that it's greater than 3.33, let's put 3.33 there as a z-score, means I needed the tail to the right. If you look up 3.33 in the table, we don't have enough information in the table to give us, so let's take the biggest number that the table has. The table goes up to 3.00 or 3.09, which is 0.9990. I will tell you the area under this part of the curve, which they don't tell you in here, is going to be 0.9996. Now on a test or on the final, I will give you something that is reasonable and you can calculate. To get the answer now, just do 1 minus that, and you're going to get that the probability is 0.0004. That is, there's a 0.04% chance that these bags will be overfilled if the bags can hold 10 ounces of popcorn. Now, part C of this really just brings together part A and B, and I'll show you how this works. What portion of bags would contain between 7 and 10 ounces of popcorn? So let me sketch the normal distribution curve again. And remember, the mean was at 8 ounces, or the z-score for that was 0. Okay. We said that the 7 ounces of popcorn was going to sit back down here. That had a z-score of negative 1.67. The 10 ounces would have to be up here. That 10 ounces has a z-score, we said, of 3.33. And the question is, what portion of the bags would contain between 7 and 10 ounces of popcorn? So what's the probability the z-score is in between negative 1.67 and 3.33? If you shade that, we're talking about this shaded region here. And what I would do is just combine together what we already have. We figured out the probability of the various tails. This tail right here, we knew the probability of that was 0.0475. This tail right here, what probability was 0.0004. What's the probability that the area under the curve is the brown region? Well, it's just going to be 1 minus the two numbers that we already found. That's why I suggest drawing the pictures of these graphs, because you can visually see it and hopefully making it easier to answer your question. Probability of this is going to be about 0.9521, or about 95.21%. Now, part D is an interesting question. It actually kind of spins it a bit. Let's read it. If a manager decides that at most 1% of the bags should be overfilled, then what should be the capacity of the bag used in the packaging process? So it's kind of a tricky question at first, but let me just draw a picture. 1% of the bags can be overfilled, which means we're talking a little tail up in here. Okay.
and that is 1%. So I'm going to write it like that. So the area under the curve can be 1%. The question is then, what should the z-score be? If we can figure out the z-score for that, we can back into how big the bag would be. So here we go. What's the probability the z-score is going to be less than some number, whatever that z-score is. We'll call this thing, this is our c. The area over here, as you can tell, is going to have to be 0.99. So to do this problem, you look at the table backwards. Go and find where is the area 0.99, and then back into the z-score that makes it happen. If you do that, you're going to notice you're going to end up looking at 0.233 is approximately where it happens. So 0.233 is the actual z-score. So this would either be at 233 or 232 would be acceptable also, somewhere within that region. So now you can back into it. The z-score calculation is this. It says, take your z-score, we're going to use 233. It's equal to your piece of data minus the mean over the standard deviation. If you solve this equation, you would multiply both sides by 0.6, add the 8, and you're going to get that the piece of data is approximately 9.4 ounces. So this is a good example of how to use the standard normal probability table backwards. If you want another example, I would listen to this one, otherwise start the homework, but here we go. A typical orange has a mass of about 200 grams. So this is our average, is what they're saying, the population average. Suppose that the standard deviation of the weights of oranges is 6 grams. Okay. If a distributor wants to throw out all the oranges under 190 grams as being too small, about what percent of oranges would be thrown out? If you sketch a standard normal curve, again, the average is about 200 grams. 190 is obviously lower, so it's about right there. They want to know what percent is smaller than 190 grams. So what we need to do is convert this to a z-score. So the question is, again, what's the probability that our piece of data is less than 190 grams? That would be a z-score is less than 190 minus 200 over 6. So the probability that the z-score is less than negative 1.67. Again, the table can't find negative 1.67. It finds positive 1.67, which is going to be about right here, because this is the negative 1.67, and it gives us this particular area. However, we know that this tail right here is going to be the same as this tail here. So the area that I boxed off in the green, if you look up 1.67 in the table, is going to be 0.9525. And if we do 1 minus 0.9525, the area in that brown tail is about 4.75%. Okay, part B. If all oranges over 215 grams are put into a special group because they are too big, about what percent of oranges is this? If we sketch it again, let's just do real quick. 180 is here. We're going to say 215 is right about there. What percent's under that curve? I'm just going to jump right to the z-score. What's the probability the z-score is greater than 215 minus 180 over the 6? So the probability the z-score is greater than 2.5. When you look up 2.5 in the table, it's going to give you this area right here, which is 0.9938. So to find the answer, 1 minus 0.9938, the area under this curve is 0.0062. So about 0.62% of the oranges would have to be thrown out because they are too big. For the homework, I'm going to have everybody skip number 12. I don't think we need to do that one. And then if you were modified for this, you want to actually do number 5. Be cautious on the modified assignment. Make sure you have enough practice on how to do this stuff. Good luck.